Okay, today we have lesson 6.1b. Our goal today is to find the composition of functions. As you can see, this is also one of your past skills. So let's get right to it. Composition is basically when you take one function and put it into another function. So you're going to have the domain, which is the x numbers of one function, going through a function and getting an answer, then taking those answers and putting them into another function. All right, we'll start off with just some basics here. And this is just working with the set of ordered pairs. Okay, so let's start off here. We're going to be finding F composition G. And by the way, that little circle means composition of G. All right, it's very simple. All you're going to do, this means that G is going into F. So let's start off with our first G number, which is 6. Our first G number is 6, and it gives us a 0. Take that 0 and look up here and find out what the 0 is for the input. So this is input, the output. That becomes the input up here, which gives us a 9. And continue that process until you've gone through all these numbers. All right, our next input is 2. It gives us a -1, and a -1 gives us a 2. So we put that there. And lastly, our input is a 9. 9 gives us 5, and 5 gives us 6. And so that is F composition G. Now they want us to find G composition of F. So we're going to do it just backwards now. We're going to be putting F function into G function. All right, our first set of numbers, we got -1, 2. So -1 is our input, 2 is our output, and 2 goes to -1. Our next number is 5. 5 goes to 6, and 6 goes to 0. Our last set is 0. 0 goes to 9, and 9 goes to 5. And that's how you do a composition when you've got the set of ordered pairs. Now let's look at a composition with equations, rather. All right? Now, let's fix this. That says f of x, and that says 2a. So f of x is actually 2x minus 5. Let's get that. G of x, let's call that 4x. That'll make more sense here in a minute. Okay, we're going to start off with f composition G of x. Now, what that means to us is that we're going to be taking the f function, and everywhere that we see an x in this function right here, we're going to be replacing that with our G function. All right, so our f function is 2x minus 5. But instead of x, I'm going to put in 4x. So there's 2x minus 5. Notice, we got the x, put in the 4x. Now we just simplify this expression, and 2 times 4x is 8x, then our minus 5. That is f composition G of x. Now we'll reverse the process. We'll do G composition f of x, which means that in our G function, we're taking out all of the x's and putting f of x in. Okay, so here's our G function. Our G function is 4x, but instead of 4x, I'm going to do 4 times this, 2x minus 5. And I'll simplify that, and I get 8x minus 20. Okay, now let's show you some of the benefits of this. All right. Let's say that I have two functions. F of x equals 2x minus 1. G of x equals x plus 4. Okay, now if I were going to do f composition G of x, that means that I'm going to be taking the G function and running it through here. So let's just come up with some numbers here for our G function. All right, this is G of x. And let's keep it simple. Domain and range. Let's just say 0, 1, and 2. Okay, if x is 0, then y is 4. If x is 1, y is 5. If x is 2, y is 6. Now then, let's run those output numbers in through this function f. Okay. So our new input is our output, 4, 5, and 6. So we would have 2 times 4 is 8, 8 minus 1 is 7. 5, 2 times 5 is 10, 10 minus 1 is 9. And 6, 12 minus 1 is 11. So our f composition g of x would give us these numbers. 0, 7, 1, 9, 2, 11. Now, on the other hand, let's say that we did the composition instead with the functions rather than the numbers here. So let's go ahead and take a look just like we did in these previous problems right here. Okay, that means I'm going to be putting g into f. So that's going to be 2x, but in this case x is going to be x plus 4 minus 1, which will give us 2x plus 8 minus 1, which is 2x plus 7. Now watch what happens when I run these same numbers through here. Domain, range, 0, 1, and 2. Alright, if I run a 0 through here, 0, 2 times 0 is 0, plus 7 is 7. Let's run a 1 through there. 2 times 1 is 2, plus 7 is 9. And let's go here. 2 times 2 is 4, plus 7 is 11. Compare this. Sorry about that. With this one right over here. Okay? Notice they're the same. This was a lot more work than this one. This one had to work at the first, and then it was easy. This one had to work all the way through. And that's why we want to do compositions. It basically saves us time.